Well, that's coming up. So I'm Pat Havens. I'm at Corteva AgriScience, and you know I ha we have to give the disclaimer that these are our opinions. We are this is not the opinions of our company or the industry as a whole. But I think uh, Mark, Eric, and I are kind of agreed what we're doing here. So great. Okay, stick that on slideshow, Renee. Okay, well, if everyone can see that well enough, let's just go to the next slide there, Renee. Okay, so I'm going to try to just back up a little bit. We've been hearing lots of good stuff on what's going on, and and Trip alluded to this. Why do we want to go to have a tiered process? And so this is a nice little diagram that Keith Solomon came up with a long time ago about if we're going to be looking at risk, which we have to note is a function of both exposure and hazard. We've really just been talking about exposure so far, um, but we do have a protection goal, and Trip alluded to levels of concern, and Chris mentioned about protecting individuals or populations and so on. Those are protection goals, and within a tiered system, this has been said before, and this is just a different way to look at it. You go from earlier tiers, which are simple, could be a simple calculation or so on, to complex, which could require a lot of data and a lot of potential work to collect that data or to process that data or to interpret that data. But going from simple to complex, you hopefully will then go from a more conservative or what we might consider a protective assessment to a more predictive one, which might be more indicative of realism in the actual environment itself. So next slide. Next. So Renee, can you go to the next slide? Okay. All right. So we talked about this in a bit, probably in both of them, and the advantages, of course, of a screening level. And Tripp said this right up front. If you can screen things out at this very simple level, then you're done in terms of assessing the risk. So by design, they are protective and conservative, but by that measure, they're relatively easy to use. Trip referred to the Terplant model, which was basically just a simple calculation, which was then incorporated into a spreadsheet. And then the PwC model, which is a model shell of some sort. However, they can represent situations that are unlikely to occur, and that's really by design. Oops. Now we see your kids and grandkids. Okay. Um, Lost it. There you go. Just leave it there. But the thing is, okay, they could be unlikely, but it's hard to characterize the unlikelihood of that. But again, if you pass that part of the risk assessment, then you're fine. And so that likelihood, but if you're trying to use it in a decision making and risk management sort of decision, without that knowledge of the likelihood, it can be hard to characterize how likely something is to happen. So, and and we sort of refer to this, the conservative elements For example, the models that were talked about at the very beginning, the water body is assumed to be right next to the field, okay, which could happen, yes, but how likely is it to happen, we don't really know. So those conservative elements can compound, and so thus if you're trying to guide mitigation and trying to make risk management decisions, at a more detailed spatial scale, for example, that can be difficult with the screen level model. Okay, so next slide. So in some cases, then you might want to go to a higher tier to become more realistic, and you can become more spatially and temporally granular. Um, we saw for the PAT model, for example, you could show that time course and look at the effects of, for instance, the schedule of the timing of applications, for example. And by doing this, you can then start to get a better feel for the probabilities of occurrence. Okay, how likely is something to happen? And then therefore you can have some better chances of defining risk management and mitigation decisions. However, as we noted, they are more data and thus resource intensive. The data may not be even available, for example. I look at Jeff's describing how they're trying to build national databases and so on. That's obviously a very massive amount of data, and how do you then represent what is representative versus a very specific field level sort of representation of the transport. And then the things with higher tier models, as you can imagine, trying to put this in a regulatory framework, if you're saying this could happen, well, what's the likelihood of that it could happen? But how do you place that in a national context, to make a regulatory decision? So that can be difficult to show, and more importantly, it can be difficult to communicate. And then putting that within a regulatory framework for decision making, can also be difficult. So next slide. Come on, Booker. There we go. Okay. And there was Chris, kind of alluded to this a little bit, but what the problem that we have, within the Endangered Species Act context, is we kind of have a conundrum. The two statutes that apply to pesticides, FIFRA is the registration law that authorizes the use of pesticides. It and the ESA have different, what we would call, risk standards. So they don't essentially have the same level of protection, for lack of a better word. Whereas FIFRA, that standard is no unreasonable risk. And then you see the wording there for ESA. And so at the initial levels of the work that we have to do, the interface between FIFRA and ESA, that's where Chris was referring to protecting the individual of a listed species. And then as it gets further along, then the Fish and Wildlife Service can make other decisions related to populations and continued existence, based on not just necessarily an individual. So, but what we run into as pesticide registrants and EPA, working with EPA, is that the registration under FIFRA is a federal action, and so it requires an evaluation. And so the way that it's working, and this is a very, very complicated and evolving process, which we're not going to get into. But essentially, EPA is determining a may affect or likely to adversely affect to a species or its critical habitat. And if they do, if it is yes, there is a may affect or likely to adversely affect, then consultation is required with the agencies responsible for the species, Fish and Wildlife Service, or marine fisheries, depending on the species. And then the services themselves make the determination of jeopardy and adverse modification, which could result in requirements or changes to the FIFRA registration. Now that's putting a whole lot of very complicated legal and policy stuff down into 3 bullets, which we don't need to get into the details of that. But save it to say, because we have different protection goals, basically, or risk standards, we run into a lot of difficulties. So EPA has worked really hard on this. It's an ongoing, evolving process. It's extremely difficult from a policy point of view, but it's also really very difficult from a legal point of view, which again we're not going to get into in this workshop. So these background documents here, I believe, will be posted on the website if anyone is interested in seeing. These are public documents from EPA and Fish and Wildlife Service websites. So next. So then, going back to the subject of this workshop, particularly, why are we talking about wetlands in an ESA context? Was as we know, there are lots of listed species that actually inhabit or rely on resources from wetlands, and the way that the modeling is represented, although Tripp showed some promising advances that are beginning, that will be out there pretty soon. And I sort of just have some questions here really for us to think about as we're going through in the context of that, and then also what we've just heard from Dennis and Jeff. The modeling of the transport into the wetlands themselves is relatively, quote in big quotes, relatively simple. Do they represent that realistically? Do we need to go beyond what the screening or even the second or third tier models are starting to do? And is that important? That's a important question to keep in mind all the time for this sort of stuff. And then the hydrology of the wetland and the dynamics of what's going on in the wetland itself, is represented in a pretty simplistic, relatively simplistic fashion. Do we need to think about a more first principles based modeling of the hydrology and the dynamics of the wetlands themselves? Okay, so as was mentioned several times, the spatial scale can be important. Okay, if we are trying to make a management decision on a individual field level, working with the individual grower that's got a particular habitat that we're interested in conserving. Okay, maybe we need to know a lot of detail, but how do we then lump those to the sub-watershed, the catchment, or beyond, and when is that important? So there's perhaps a diminishing return that you can think about, trying to go to extremely higher tier model, very difficult, very spatially specific, but does that help you make a regulatory decision? Maybe, maybe not. So you have to balance how high tier is too high or how high tier is high enough, to make the decisions that you want to make. So it all depends upon the decision that you're trying to make and at what spatial scale you need to do it. So I hope that's helpful for folks to maybe put a few sort of leading questions in your mind there. And so I think that's what I've got for now. I've got pretty pictures on the next slide of some lovely endangered species that those of us that are registrants have all had to deal with most of these in the last few years. So our favorite in the middle is the Indiana bat. So I'll take a question or two if anybody has one. Back to you, Bernie.